welcome back. This is another session where we'll be focusing on how to deal with weather data. In our last session, we dealt with the tax data and we saw all those things that we needed to see. We saw how the file is being saved in S3, how the schema is created, and how the table is being created. So we're going to do the same thing. But before we go ahead, we're just going to try to see um, what our bucket look like right now, the files and folders in our bucket. So we can see we have 3 folders, and that's what we expect. Okay, and when we double check here as well, we can see we have 3 folder. That's awesome, guys. All right, now for this weather data, I've showed you how it looks like before. It's basically in JSON format, and because of that, this is going to be a little bit different. Okay, now for the text data, we didn't have to create the schema ahead of time, right? So but in this case, we have to create a schema. Okay, we have to create a table structure ahead of time because of the nature of the data, right? Because inherent in this data is it has just some key value pair. It also has arrays as well, so we need to deal with that, right? So the first thing we're going to do here is that we're going to import all the various functions that we need, and then we're going to create the schema here, and also we're going to create the schema that has arrays, or it has some nested columns within that particular column, and then this one that has arrays as well, we have to deal with that accordingly. So let's run this. It will create the right schema that we need. All right, now that we have the schema, okay, let's run this. So basically we have the structure that we need, and remember we call this schema w_schema. all right, so we're going to call that schema here. Basically we want to load the raw daily weather JSON into a data frame using defined schema. Okay, so now this is a variable, and we are saying spark.read. What's the schema? The schema we described, we've seen earlier, we just defined, and then we said what's the format is a JSON file, right? And we are saying basically that this is a path, right? If you look at it, it's exactly the same path that we have the file. Let's just double check that. So we have landing, we have New York, we have weather 2005-07, and then we have the file. If we come here as well, it's the same thing. Okay, and then we say we want to display the data. All right, so let's quickly run this code. All right, now we can see now it's beginning to show us in table-like structure. We can see it's just one record, right? But in that record we have daily units, and you can see we have other columns that have been nested in this object. You can see time, temperature, minimum, maximum, and precipitation sum, which is what we're going to use for our rainfall. And also in here you can see we have some arrays of data in here, right? So we need to be able to flatten this JSON file such a way that we'll be able to extract exactly the data that we need in a table-like structure. Okay, now for us to flatten and categorize, we have come up with this code, and I'll quickly go over the code. So basically, again, we are importing the right functions that we need, and here we are basically selecting the columns that we need. So we're selecting latitude, longitude. These ones, they are just straightforward. There is nothing we need to do to those ones. But when we look at the daily unit, we need to flatten that as well. And so what we do, the way we flatten it here, we said daily unit dot a wildcard here. So, and it's basically referencing all the nested columns within that object. Okay. And then here we are basically say combine daily arrays into a single array of struct and explode into rows. Okay, and then we're saying that alias the exploded struct as daily. So basically we are still once this is exploded into uh, once it's exploded into different struct array, single array of struct, then at that point we still want to use daily to call it. Okay, and then here as well, this is where we'll then begin to flatten the first one. You can see for the daily unit, we are calling it, at this point we have access to those columns, so we are calling it unit time format column temperature. We're calling it unit temperature max, and these also we are calling it unit temperature minimum, and precipitation, some we are calling it unit precipitation minimum, right? Unit metadata for precipitation. And then here we are now saying daily dot time as dates, and then also we're beginning to actually access the daily columns as well, which is temperature, time, maximum and minimum, and precipitation, right? And then there's one more last thing that we did here. Now we now perform additional transformation, saying that if our precipitation is less than 2, then we want to call it dry or no rain. So we are basically categorizing the precipitation, right? So if precipitation is less than 10, light rain; if it's less than 30, moderate rain; and if it's less than 60, heavy rain; if it's less than 100, very heavy rain; and otherwise we're going to call it extreme rainfall. Okay, and then that's exactly what we did. So we're just going to run this, and we should see those additional file added. Now please take note that this ones is the exact data that we have from source. So this is going to be our our bronze data frame, so our bronze data, and this is going to be our silver data because we added some transformation. Okay, and so here we can see all the data is coming as expected, and then we see this new attribute that we added. Now we're going to get to some interesting stuff here. Okay, now because we're still looking for the gold layer, right? So we are going to take so basically we are going to go back to the daily, the trip data that we have here. You know, we said we're preparing the silver data for the gold data, right? So basically this silver data that we have here, we're going to then join it to get the aggregate, to get that aggregated gold data that we need, the fact table. All right, so how do we do that? So we basically call this variable, and we'll refer to that silver clean df, and then we select, which is this data frame right here, silver clean df. So then we select the exact, because we have a lot of columns there, but we only need these 4 columns, right? So we select the 4 columns that we needed, and then here we are just basically going to say that do a left join. So basically this is going to be our final table, and we are basically saying that this table, do a left join, and then join it using left. If you look at the df tags silver aggregate, is basically the name we gave the silver data here, the aggregated data for the tags trip data. You can see we call it df tags silver aggregated, right? So basically if you come here and you run, just to make sure that we're on the same page where I'm going back and forth, but you can see that it's the same thing that we are using here, and then we are doing a left join using the date. So the date has to be the same, and then we are using the left join for that. All right, and then we are displaying it that. Let's quickly run this. All right, now that we have run this, right, we can see that this is what our final data looks like. We can see the trip data, and then also we can see the weather data, which is great. Now there's one thing that we are yet to do. Okay, if you remember when we're doing the tags one, we have to save the file, create a schema, and then where we had to create a table, right? That's why we have these two tables, right? And I think we have one more. Oh yeah, these two tables because we've not created the gold table. Okay, so we have these two schema, and then we have two tables in there, one for browns, one for silver. Now, because we are using this code over and over, so what we have gone ahead to do is to convert this to a function, right? So in a way that we can reuse this function to perform those three tasks, right? So the first is to create a schema, the second will be to save the file, the third is to create the table, right? Now, so what we have done is that we are now creating a function. We call the function save and register delta table. We have four arguments needed: df, target part, schema name, and table name. And I've put some instruction here. Basically, we're saving a data frame to the specified part as a delta table and register it in the Hive meta store. So the df data frame stands for this Spark data frame to persist. The part here, which is called target part. Okay, I can actually call this target part. The target part here is saying that the DBF, which is Databricks file system, or S3 part, where the delta table will be saved. The schema name is calling the Hive meta store schema to create or use. Table name is basically the name of the table to register. All right. Now, what we are saying here is that run this, and then whatever schema name that has been provided, put the schema name here, and then whatever part that has been provided, target part that has been provided, put the target part here, and then also put the schema, put the name, and then the target part, and then create a table using this code. Okay, I know some of us, you might not be used to Python before, but just just know that's what we are trying to do. We are creating a function just to be able to reuse it for similar use case. Okay, so let's run this. All right, let's run this. Now that we have run it, now so we're going to start with the bronze New York City for the weather data, right? And we have called the table name daily weather. We have called this. Okay, we need to change this one. This has to be go under weather. Okay, this has to be under weather. So this is bronze New York City weather 2005-07 daily weather, and then the schema name is going to be bronze New York City, which we have here, but then the new table is going to be daily weather. Let's run that and let's see if it works. So we should see two tables here, right? So now let's refresh, let's check here, and now beautiful, we now have two tables, right? That means it's working. We're going to do the same thing for silver as well, and then we're going to check S3 altogether. Okay, so we're going to change this to weather, and then we're gonna see daily weather, but in silver, and we're just gonna call this, let's call it silver daily weather, so we distinguish it with the bronze layer. Okay, this is this should be silver. So we are sending it to this silver schema. Okay, and this is our table, and then we are calling it clean daily weather. Okay, let's call this one clean as well, then clean daily weather. Okay, and then we're gonna run this, and then we should have two tables here as well. Okay. So clean daily weather. Okay, we say clean daily trip, clean daily weather. This is great. And then for the gold, because for the gold we only have, we're gonna call these taxi, because it's a combination of taxi, the trip data as well as the weather data. So we're gonna call it taxi, or we call it trip underscore weather 2005-07, and we'll call it final daily trip weather. I'm okay with that. Gold New York City, and then final daily trip weather. Okay, so let's run that. We should see a new schema here, and then we should see the new table. All right, so it's run successfully, and then let's refresh. Oh, okay, let's see. It did run, but we are not seeing it right here. Oh, okay. I know the refresh wasn't working. Okay, beautiful. Now we can see the gold. Beautiful, and that's the data we really need for our next analysis. Okay. All right, so let's have a look. Let's look at this. Everything is looking good. There's a catalog, the schema, and then we have the table itself. So let's run that. Let's see what that looks like. All right, so we see it's coming as expected. That's great. That's great. All right, so this is where we're gonna stop for now. And before we stop, let's just double check all the ones we just did. So remember, we save the weather data, and we can see it's right here. Right, this is the weather data. Okay, and we're gonna just go to gold because we know it's in silver. We can check silver as well, but we can see beautiful. And lastly, we're gonna check silver, and then we see weather 2005 clean, beautiful, and then we see the delta format. All right, so everything worked as expected, and that's where we're gonna stop for now. And in our next video, we're gonna be looking at, now that we have these data, right? Now, what's the next thing we need to do? We need to be able to provision it in the Redshift. Okay, we need to get the data into Redshift. Now, all the data in Databricks, but we need one of them that the business can actually use in Redshift, and then we can push it to Power BI. So we are done with all of this process. We just need to run some few more lines of code and some stuff so that we can get the data in Redshift. So this will be the end of this video. I know this is interesting so far, and I'm seeing you guys, you are getting along. Let us know what you think. Put your comment in the comment section. Like, share, subscribe, and thank you for watching. I will see you in the next video for the next session.